All right, welcome everyone. Hope everyone's having a good time at Build so far this week. Is everyone enjoying their time? Yes, good. All right, well my name is Luke Hoban. I am a program manager on the JavaScript team at Microsoft. I get to work on the team that builds the JavaScript runtime that we ship as part of IE9 and IE10 that is now part of what's powering building Metro-style applications for Windows 8 using JavaScript and HTML5. I've also, over the last year or so, had the opportunity to work on the experience that we're able to provide for allowing JavaScript developers to access all of the power of the Windows runtime from JavaScript without having to move and write their code for Windows in a different language. And so what I'm going to be talking about over the next hour is some of exactly what that experience feels like to take advantage of the Windows runtime from your JavaScript applications. And to get started and sort of set the stage for why you might be interested in the Windows runtime as a JavaScript developer, let me give you a sense of kind of where, as a web developer coming from that background, where the APIs available to you are going to be coming from in this environment. So in IE9, we shipped in the web platform a ton of APIs. A lot of you are probably web developers out there building websites today, and you have available to you a ton of APIs. You can build extremely rich applications already on the web using IE9 and using standards technologies targeting many different browsers. In IE9, you can see here we shipped several hundred APIs across both the web platform, things like the DOM and the XML HTTP request APIs, and things like that, as well as in our JavaScript runtime, where some of the core libraries like arrays and regular expressions and some of the basic programmability constructs are available. In IE10, we're adding a ton of new APIs on top of that, about 30% new APIs being added to the platform. And if you think about that by itself is an enormous growth in the capabilities of the platform in terms of what we can do. And there's sessions here that will go into more detail about all of these new APIs that are being added. But to give you a sense, there's a lot of new stuff. Now, when we go over to Metro-style applications built using HTML5, you have access to all of these libraries. So everything you can do with the web platform, you can bring that technology, you can bring those components, you can bring those assets, and you can start using them in your Metro-style applications. But in addition, you also have access to the Windows runtime. And the Windows runtime is a huge set of APIs. As you saw Alesh mention yesterday, the Windows runtime is Windows. This is all of the APIs that make up what Windows is. And you have access to these from JavaScript now. You have direct access to these APIs. And so you can use both the web platform APIs that you're familiar with, but then when you need to do something that's fundamentally about connecting to Windows or some of the new user experiences that are available that you saw yesterday, you have access to all of these APIs that are part of Windows. And so this isn't a pick which one you want. This is you have all of these APIs available to you to program against. And there's a lot of them. And so what we're going to be talking about today is kind of going into depth on the Windows runtime component and how you can go and leverage those APIs and some of the ways that those are the same and slightly different than the web APIs that you're programming with in other parts of your experience. So the key message there, I think, is really that the Windows runtime is a rich set of APIs. When you're building Metro-style applications using JavaScript, most of your code is going to be the same web platform code that you're used to writing. But when you want to really take advantage of the unique things that are available in this environment and building a Windows application instead of a web application, you get to leverage the WinRT, and there's a lot of ways you can do that. So to give you a sense of some of the experience and just a quick look at this, I'm going to jump into Visual Studio and give you a quick tour through using the WinRT from JavaScript. So here we are inside Visual Studio 11 Express for Windows Developer Preview. And so what I'm going to do is just create a new project. I'm going to create the blank application. And we can see, as you saw yesterday, we have a series of templates available to you. All of these templates are using HTML and CSS and JavaScript, but also have available to them the WinRT by default. So if I go and just create this blank application, we'll create some files, and I should be jumped into my default HTML and my default JavaScript. So to give you a sort of bare bones thing, we're going to delete this, and I'll just type in some basic things and give you a sense of what the feel of working with the Windows runtime looks like. So the Windows runtime in JavaScript is exposed entirely underneath a single object. So that single object is called Windows. When you go Windows dot, underneath here, you'll see we have a hierarchical arrangement of all of the APIs that are available as part of the Windows runtime. Now, as you saw, there's a lot of APIs in Windows. And so it was a really important design point to make sure that we didn't just go and stick all of that in the global environment and add, another 700 or so names in the global namespace and pollute that. Instead, we wanted to make this easier to discover, better organized, and sort of categorized for you within a name sort of hierarchical model here. But these are still just JavaScript objects. So I can say Windows dot, and I can go and look in the devices category, for instance. And then under devices, you'll see there's a ton of capabilities here. I can do things with my printer. I can do things with enumerating all the devices on my system. I can do things with sensors. So we've got things like accelerometers and gyrometers and inclinometers, all sorts of things that are available that may be in my machine. And we also have things like file access. You saw a couple of demos yesterday that touched on how we can get a rich feel for accessing the Windows file system. So we have APIs for working with files and folders. We have APIs for working with local application data that allows me to store roaming and local settings for my user. And there's a whole bunch of APIs underneath here, and there's sessions all throughout the rest of the conference that go into detail in each of these different categories of APIs that are available. The one I'm going to sort of do, this is my first demo here, is the media capture API. And we've seen a couple of demos showing off how you can use this media capture. But I'm going to use the camera capture UI. And so just like you might expect from JavaScript, I can go up to this and I can say var dialog equals new. And I can actually new up an instance of this Windows runtime object. And this now gives me back an object called dialog, which is one of these Windows runtime objects. What I have a handle on right now is some Windows capability, some Windows object that I can then program against within JavaScript. One of the things to note on the side here is that we actually have given you, a much improved IntelliSense experience as well inside Visual Studio 11 Express. And so for JavaScript, you'll see we're getting quite a lot of good IntelliSense feedback here. And that's all powered by the JavaScript engine, which is running for IntelliSense. In particular, for the Windows runtime, you'll see we can get rich information about what's available in the Windows runtime itself. And so, for instance, for this camera capture UI, we see there's a bunch of different functionality available on it. You'll see this functionality kind of splits into two categories. One of these is things like has own property and toString and value of. The properties that you're used to seeing on object.prototype in JavaScript, these are all the things that every object in the system is going to have. But in addition to those, when we are exposing this object into JavaScript from the Windows runtime, we get the objects, the functionality on those objects, which is made available by the Windows runtime. So in this case, that's things like the photo settings, which would allow me to control how the photo I capture is taken, as well as this function capture file async. And you'll see we pull in a bunch of great metadata about that function to give you sort of help in line for coding against these APIs. Now, I'm going to be demoing this, and as you notice, the IntelliSense here is very helpful and tells me that there's a couple of capabilities I might need if I want to use this API. So before I actually go and run any code, let me just go open this up and make sure I've declared that I'm going to use the webcam capability. I'll just close that. What I'm actually going to do, I'm going to delete this code, and I'm just going to run this empty app, and we're going to actually write some code at runtime. So here we go. I have my empty app, just a blank screen there. What I'm going to do is switch back into Visual Studio and go into this great JavaScript console that we have available. So the JavaScript console is a tool that you're probably used to as a web developer. In almost every modern browser, we have built-in developer tools which allow us to work with the DOM Explorer or with inputting JavaScript code and executing that on the fly. And so we've actually gone and integrated a bunch of those tools into Visual Studio now so that you can use those same tools you're used to while building Metro-style applications using JavaScript. And so what I can do using the JavaScript console is I can go and look at some of these objects that are made available from the Windows runtime. So for instance, I mentioned that the Windows object is actually a real runtime object available in JavaScript. And so when I look at Windows, we'll see that this is an object at runtime. And I can sort of drill in and look at what's on this. So we can look at the devices, we can look at sensors, We can keep drilling through and look at all the capabilities of the system that are made available at runtime through these objects that are exposed off of this one root Windows object. Let me just close that. And so we can go and we can use that same API that I just showed you. So I can say new windows.media.capture. And I'll get the, oops, misspelling that. So I'll type this in. There we go. So now I can new up one of these instances, just like I did in IntelliSense, and we could see the IntelliSense experience with that. But at runtime, I can also see that. So I can actually see at runtime what this object that I got back looks like. And so I can interact with a live object. I can look at what the default settings were for photos and videos. And I can play around with these APIs and explore them using the console here. So to call this capture file async, I actually need to get a mode. So let me just type in windows.media.capture. Capture mode.photo. So I'm going to take a photo using this. Now I'm just going to use this capture file async function that's available on this API. And you'll see that that is just exposed like a normal function in JavaScript. So this is just an object with a function available on it that can take that picture. And so I'm going to say dialog.captureFile async, and I'm going to pass in the mode. And this is actually an asynchronous function. Like you heard Jensen and Alesh and others talk about yesterday, async is a very important part of this platform. We want to make sure that all of the applications built using this platform have a great user experience, that they don't ever hang the UI for your users. So that means that when you're writing code, you're going to be writing code using async functionality a lot. And I'll talk a lot more later about some of the ways in which we're making async available in JavaScript. But for right now, I'm just going to use the then, which is the way that we respond to what happens after the asynchronous operation completes. And the asynchronous operation is going to complete and give me back a file. So it's going to tell me that the file for the image that was captured is here. Go and do what you want with it. And so I'm just going to store that into a variable called capture file. So I ran that piece of code. I got back an object. But if I switch over back into my application, I've actually now launched that whole experience of capturing an image. The first piece of that is that it asks me whether I want to allow this application to use my camera. And of course, I do in this particular case. And now it launches me into this camera capture UI experience. And so I'm just going to take a picture using my camera. There we go. And it's great. Right here, with just one API call, I've been able to incorporate this whole, basically, experience that Windows offers me around capturing images. I don't have to program. There's all kinds of different options here about picking which camera device I want to use, what resolution I want to take my image at. I can even come in here and change what part of the image I use. And so all of this allows me to control the camera capture experience using a whole bunch of UX that Windows has provided for you. Now when I come back into the console, I've finished that operation, and now I can look at that captured file variable, and we see that there's now an object here because that async operation completed, and I stored that into that variable. And this object that I have now is a representation of that file as Windows understands it. So this is all of what Windows knows about files. This is really, the file API for Windows that I now have available, and I have all that information available to me in JavaScript. And this includes things like the file attributes, whether it's read-only or whatever, its content, its MIME type, the display name, and everything down to, the full path to that object. Now, in addition, you see that all this information is being exposed just in exactly the way you would expect as a JavaScript developer. The strings are coming back to you as strings. The numbers are coming back to you as numbers. All of the data that's available inside Windows, which is using all of the C++ and C implementation details of Windows, it's being exposed here to you as a JavaScript developer in the same natural way you would expect, as a bunch of objects with some functions on them and properties that return strings and numbers, the same kind of data you're used to. So the next thing you might expect as a JavaScript developer is like, how do I go and take this file and do something interesting with it in my HTML UI? So what I'm going to do is I'm just going to create an image element. create an image. And now I'm going to get the URL that I can use to bind to this image. And one of the things that has been done in the HTML5 standards body standards recently has been the introduction of the ability to create URLs for blobs and other kind of opaque data that are temporary URLs that can be used during the lifetime of a web page, but that can be bound to things like a blob, which is an opaque container for a file. And so one of the standards APIs that we have added into IE10, and it's available inside this environment here, is url.createObjectURL. And what that does is let me pass a blob or some other kind of data in and get back a URL for it that I can use elsewhere inside my environment. And so I can just actually pass that file that I captured from the Windows runtime directly into this API. And when I do that, I get back a URL. And this is a simple blob schema here that I can then go and use elsewhere in my application. And so since I created an image tag, let me just go and set the image source. And let me go and say document.body.appendChild image. Okay, so there we go. We actually created an image. It found out the size of it from the image that was captured. And if I switch back to my app now, we see I've actually bound that directly into my HTML UI. So this is pretty cool. We've been able to take data from the Windows runtime, pull it into JavaScript, play around with it in the interactive environment, and then go and put that up into some user interface. But there's one more kind of cool thing I want to show doing. Since we have a file, we can also pass that file to other Windows runtime APIs and do other things with it in the Windows runtime. And one of the things we can do is we can use an API called windows.system.userprofile, .userinformation, .setUserImageAsync. And I'm just going to pass that, the captured file, and I'm going to just use then to tell it I don't want to do anything after this asynchronous operation completes. And when I do that, we'll see that it asks me whether I want to allow this application to go and change my user tile. And if I click change, what I can do now is go back into my start menu. And if you can see up here, it's actually now using my new image that I just took of whoever's sitting here in the front row. So I've actually now been able to integrate and automatically use that functionality that's available in Windows to go and modify things about the user's experience inside the shell from my application from JavaScript. And if I go and actually lock the PC, you'll see that there's a bigger version of that image. So we actually have that now as our user image. Okay, so that was a quick demo of some of the Windows runtime experience. Let me jump back into some slides really quickly. So what I want to talk about next is sort of some of the basic concepts of how we map the Windows runtime into JavaScript. And one important starting point for that is kind of how JavaScript fits into the overall environment of what you saw yesterday in terms of the architecture of Metro-style applications on the platform. So one of the key aspects of the platform is that a lot of the APIs that have been made available are made available in this Windows runtime API stack. So to enable all these different languages and all these different user interface presentation tiers to be made available, we need to make sure that the APIs that powered the platform were written in a way and made available in a way that wasn't specific to each one of those environments, that was actually general purpose and could be consumed from any one of the environments on equal footing. And so we did that. All the APIs and all the functionality of the sort of core platform is made available down there in the Windows runtime APIs. But of course, sitting on top of that is the same JavaScript and HTML experience that you're all used to. Now, one of the interesting aspects of designing a set of APIs for use amongst all these different languages is we need to make sure that the design patterns in those APIs are intended to work equally well in all these different environments. And so that was one of the really interesting challenges, was getting the APIs to be sort of consistent, but still really nice, have a really nice natural look and feel in each one of these different environments. And I'll talk about several of the ways in which we've gone and made the way that we expose the Windows runtime APIs natural and familiar for a JavaScript developer. So the way that we sort of make this possible is we make the Windows runtime APIs available using a platform-neutral metadata. So we describe all these APIs in a way that isn't bound to any one of these runtime environments and just can be equally consumed from any one of them. And that means the API needs to describe some of these concepts that are used in some of the strongly typed languages that run on this platform. So the Windows runtime describes concepts like namespaces and classes and methods and events. And so what we want to do is take those concepts and expose them to JavaScript in a way that's just as simple and familiar as what you have when you're working with anything else inside the JavaScript environment. And so let me go through a couple of the examples of how these things map. So the first one here is namespaces. So as I mentioned in the demo, namespaces just project as standard objects. So these are objects which act like any other JavaScript objects, but they give you give you access to a hierarchical view of the components of the system. And so we can do things like we can bind variables to those if we want to use sort of aliasing to make the names shorter. If we're going to use a particular namespace a lot, we can just bind display to windows.graphics.display. Now, namespace objects can contain other namespace objects. But as well as that, these namespace objects can include both classes, which are things that we can new up and instantiate instances of. And they can also contain enums, which are just going to be containers for some standard constants that we may want to use when programming against one of these APIs. And both of those are just standard members of a namespace object. Now, once I've gotten through my namespaces, I want to get to some functionality that is going to be made available to me. And that is primarily in the Windows Runtime made available through Windows Runtime classes. Now, Windows Runtime classes project just like any constructor object that you're used to in JavaScript. So there are objects like message dialog here, which I can new up. And I can call the constructors to new up instances of these objects, and then I can access the members on those. So in this example, we see I'm newing up two different things. I'm newing up a message dialog and passing it a string. And I'm newing up a UI command and passing it both a string and a function. Now, one of the things I should mention here, I'm showing off a couple of different APIs. On the previous slide, I was showing off an API around using display settings, so an API that made available to you all the information about the display that your application was running on. If you wanted to carefully control the assets that you were using in your application, you get access to the DPI of the system device. You get access to the screen resolution and lots of additional information. In this example, I'm showing the pop-ups APIs, which are the way that you can display sort of warnings or information to the user in a sort of modal style, but without interrupting the availability of the application. And so these are nice APIs for kind of building Metro-style applications. Now, as soon as we have classes, the other thing we want to talk about is members and properties, the things that hang off of our class instances. And so for Windows, the same example here, we see that there's several different kinds of members that are available. So for one, we have access to members like a property, default command index, which I can get and set to be a number. And so this is just like you'd expect from a DOM property that has a number. We can also access properties like commands, which I'm just going to get the value of. In addition, we can pass data into Windows Runtime APIs. And so we can pass lots of different kinds of data into the Windows Runtime from JavaScript. So we can pass strings, we can pass numbers. In the second example there, you see we can pass functions as callbacks for an API that wants to call back into JavaScript later on. And we can pass collections. So the current custom commands is a collection of objects. We can pass that into Windows Runtime, and that'll get passed into a native component as a native collection. And so we can program against these APIs in just the same ways that we would expect for other APIs in the system. Now, the one additional kind of member that is available is events. And for events in particular, we wanted to make sure that the way that we exposed events really lined up with what web developers and JavaScript developers are used to from the APIs they work with. And so we project events using the same DOM events pattern that you're probably familiar with from the DOM and from other web APIs. And that pattern uses both the add and remove event listener functions, which we can pass the name of the event and a callback method. And it also includes a sort of on position changed or on query submitted or whatever function property that can be set as a single cast event invocation. And so this means that your programming experiences for events, just like some of the other members we saw, is going to be really consistent across these two pieces of your applications. Now, as well as exposing these add event listener, remove event listener pattern, DOM events also exposes the actual event object you get passed in your callback functions and provides some standard functionality on that. For instance, we can get the target of the event invocation, or we can get the name of the event that was invoked, so we can differentiate in our callback. And so a lot of that same information we make available on the exposed Windows Runtime event object. And so in this case, we see like ev.target is going to be the same as what you'd expect as a web developer. But in addition, any of the custom properties that are available from whatever particular Windows Runtime event is being processed, those are also available on the object as well. So in this case, the onStatus changed passes a status property, and so we have access to that information as well. This is exactly the same experience again that you would get with DOM APIs. And so with that, let me go into sort of the next kind of phase of demos. What I want to show off in the next two demos is going to be the ways which we can take a Windows Runtime, take a Metro-style application written in JavaScript and extend it and give it new capabilities and give it new features using APIs from the Windows Runtime from JavaScript. So what I'm going to do here is switch over to another instance of Visual Studio. And what I have here is a simple application for sort of an encyclopedia application that I can run as a Metro-style application. So I'm just going to run this to give you a sense of what the application looks like before we get started. So this is an application which allows me to sort of browse encyclopedia content that's being pulled down from Wikipedia. And so I can go in and I can look at things like Einstein field equations. I can scroll through and look at this content that's pulled down and displayed inside a Metro-style application. I can click around inside some of these topics. I can see some of the images, and I can click around in the topics. And this is a basic Metro-style application. Now, although this application is using all of the same kind of design principles that you saw already from Jensen's talk yesterday, and this is already sort of embracing some of the Metro-style application principles, this application is, though, just using primarily, almost entirely, in fact, standard HTML5 technologies. So almost all of the code here is just HTML, JavaScript, calling standard DOM APIs and standard XML HTTP requests, and a lot of CSS for styling this application. So the dominant aspect of this is just a bunch of additional web code that all of you are very familiar with. And in fact, this application is only a few hundred lines of code added to the default out-of-the-box templates. So this is a very easy kind of thing to go off, and if you have skills as a web developer, you can go off and create applications like this in the Metro style. But what I really want to emphasize is how we can go and take an application like this and extend it to add Windows Runtime capabilities. And so the first thing I'm going to add, there was a couple of demos yesterday, I think, where they touched on the search capabilities of the Metro-style platform. And one of the really great things about this sort of environment that you get to write your apps in is that it takes care of a lot of common tasks for you. It takes care of sharing, and it takes care of search. It takes care of connecting your application to devices and printers. And so what we're going to do is we're going to use the ability that Windows provides to do search from our JavaScript application. So what I'm going to do is create a search pane object here, and that's going to be Windows.application model. What's going on there? We'll do search pane equals Windows.application model .search pane .get for current view. Now this search pane is going to be an object we can use to interact with the search pane that appears, as you've probably seen, on the right-hand side of your screen. And so this search pane gives me access to a bunch of different pieces of Windows. So this gives me access to the on query submitted. And I'm going to do this. And so on query submitted means when someone submits a query through the user interface that's available from Windows, I'm going to get invoked and told what query that user submitted to me. And so let me just come in here and do EV, and I'm going to set a breakpoint. I'm just going to run this application as is. So what I can do now is I can open up the search pane, and I can search for something like, I can search for Windows, hit enter, and we see we break into my breakpoint there inside this event. So you see just some really simple JavaScript code, and Windows and this user experience is actually calling back into my JavaScript application. So this already is pretty amazing that I'm able to actually have this old Windows Chrome that's going on in the Metro-style environment to actually invoke my JavaScript code. But then I can go and look at what this looks like. So the object I got has a few pieces of information on it. As I mentioned, it has things like the target and the detail and the type of event that was fired. But it also has the language, so the user's language. If I want to go and make sure I'm submitting this query in the right locale, I can do that. And also the query text of what the user passed into me. So what I want to do is I want to actually make my application navigate to that. So I'm going to create a topic. So I'm going to create topic from title. I'm going to pass ev.queryText. And now I'm going to actually use Win.js. So Win.js is a set of libraries we've made available for sort of more easily working with some of the primitive concepts that are available inside Metro-style applications. And one of the nice convenient helpers we have is Win.js.xhr. This is probably something that's familiar to you if you've used some of the helpers like $.ajax in jQuery. Just a convenient helper for working with making XML HTTP requests. Oh, actually, I don't want to do that here. What I want to do here is I want to use Win.js.navigation, and I want to just navigate my application to a different page of the application. And that page is HTML/detail page, which, as we saw in the application when it ran, is just the page where we're going to show details about one of my topics. And I'm going to say item is the topic. So let me just go and run this one more time. And when I go in here, and I type in Windows again, now we see we navigate directly to that page inside the application. So that's pretty amazing. Just with a couple lines of code, again, we didn't have to write all that UX. We didn't have to go and figure out how to integrate a search button into our code. We didn't have to figure out how to accept the user input, all that kind of thing. All we had to do was write these lines of code, and then we get to leverage the fact that Windows already has all this user experience. So that's a really simple thing, but it turns out that the search pane actually provides a bunch more functionality that we can hook into. So one of those is I can actually offer suggestions to the search pane that it should show to the user if I know maybe what they're typing. So I can do sort of predictive things. I can take the prefix of what they've typed, and I can say, hey, here's some things that are going to start with that are going to be useful for you to maybe type in. So what I want to do is, actually, since I'm not getting IntelliSense right now, I'm going to quickly actually just restart. Restart this instance of Visual Studio. So I can actually, I want to show you what all of these, what the APIs that are available on these objects look like. And that's going to be easiest if we can get IntelliSense to show that to us. Okay, so we're back inside Visual Studio, and now when we type in search pane dot, we're actually getting the IntelliSense that shows us what's available there. So as you can see, as well as this onQuery submitted, there's a bunch of additional events that the Windows runtime is going to allow our JavaScript code to hook into. And so in this case, what I want to do is onSuggestionsRequested is an event which I can hook up to actually pass suggestions back to the Windows runtime. So what I want to do in here is I'm going to go off and get a bunch of suggestions, but that could actually take a long time to get those suggestions. It's going to require making a network call to go and get back the suggested items. And so because that could take a long time, and this is an event that's firing to let me know, I want to let this event know that I am not potentially going to finish by the time the event is finished, and that I'm going to want extra time. And so there's a pattern that's being used inside the Windows Runtime APIs called the deferral pattern, which allows me to just get a deferral object. And then when I'm done and I've got the results that I want, I can just say, I'm done. I don't need to hold on to these suggestions any longer. So I'm going to do that, and then I'm going to get a URL that I want to hit to get some suggestions. And it turns out there's an API available out there that Wikipedia makes available that can get some suggestions. And so I'm just going to take the, I'm going to encode URI, the query text, and pass that in. And now I'm going to use that winjs.xhr that I mentioned to just access the URL. And when that's done, I'm just going to get the XHR object and respond to it. So let's take a look at what that XHR object looks like. So I'm going to run this application again. And again, we're going to go in and search. But this time, as soon as I type a single character, Windows is going to be invoked and go and ask me, what is available that starts with a W. And so what's happened is, as soon as that's happened, I've gone off and made my XML HTTP request. And now I'm back inside my breakpoint, and I have this XHR object, which has all of the things you would expect. This is just the standard XML HTTP request object. But the response, you'll see, is this data here that's available about all the different topics that start with a W. And so we see that this data is actually in a JSON format. So what we can do is we can just close this and take a look at what that data actually looks like. Take a look at what that data actually looks like inside here. One of the APIs we have available in JavaScript that's part of ECMAScript 5, the most recent version of the ECMAScript standard, is built-in support for JSON. And so just like in IE9 and IE10, we have built-in JSON support in JavaScript here. So we can just do xhr.response, json.parse. And we see we get back an object, which is an array. And that object has two members, the second one of which is actually all of the elements that I care about. So with that, let me come in here and actually write the code that I want. So I want to write var data equals json.parse, xhr.response. And then I'm actually going to take the request object I got. It has on it a search suggestion collection. And I can append some suggestions to that. And the suggestions I'm going to append are that array of all the different strings that I want to add back into the UI. Now, the last thing I want to do is I created that deferral object before. So I want to indicate that I'm actually finished now, that I've added those into the UI. And I'm just going to do complete. So let me stop that running and restart it again. Now we're back in our application. If I now search for Windows, you'll see as I'm typing, I'm actually getting live suggestions coming in from Wikipedia. And all this is being integrated in from my JavaScript code. So all that information is flowing sort of both ways. I'm tightly integrated between the JavaScript code I'm writing, the XML HTTP request I'm using, and the Windows runtime that I'm using to display this. Okay. So one of the key things to kind of point out there is all of that code I just added to add that functionality in my application fits just on this screen right here. And like I mentioned earlier, this is going to be your typical experience working with the Windows runtime. The majority of your application, the UI of your application, the logic of your application is just going to be standard JavaScript and HTML. But then when you have targeted features you want to add, where you want to hook in the search capabilities of Windows or the share capabilities, you're going to write targeted pieces of code like this, which leverage that functionality from the Windows runtime. Okay, so with that, let me switch back into a couple more slides. So in the next section, I'm going to go through a few more details about how the Windows runtime components are made available within JavaScript. So overall, you've already seen that many of the concepts that you're familiar with as a JavaScript developer are exposed. The Windows runtime is exposing those concepts in the same, in a similar way for JavaScript. But there are a few new patterns, and some things like what we saw with the use of async. There's a few patterns that we're leveraging that it's useful to sort of talk a little bit more about. So let me talk about some of the things that are very similar and a few of the things that are a little bit different. So For basic types, just like you'd expect as a JavaScript developer, we want to make sure that when you pass data into the Windows runtime, we take care of converting that in whatever way we need to pass it correctly into the Windows Runtime API for you. So you can use these APIs which from C# are these strongly typed APIs, but you can use them in a natural way from JavaScript as well. So for instance, when I have an API here like the data reader and data writer, which allow me to write, if I'm writing out to a file and I want to write really controlled sequences of bytes into my file, there's a Windows Runtime API that allows me to do that. And if I want to use that API from JavaScript, I may want to call this write double method here. And I'm going to call that, I'm going to pass in maybe a string, the number 3.14. And for JavaScript, we actually do all those conversions for you. So in all these cases, these will all do the same thing. They'll all ultimately make the same Windows Runtime call on your behalf. So, so most of the basic data types work just like you'd expect. We coerce automatically to strings and to numbers and to every one of the other basic data types. There's a couple of interesting examples in the space of basic data types as well. And one of those is int64s. So JavaScript doesn't actually have any int64. It has all numbers represented as sort of floating point numbers. And so when we want to pass int64s from the Windows runtime, we actually have made sure that that is possible. You can actually pass an int64 into and out of JavaScript from the Windows runtime. But if you actually use that number from within JavaScript, you may not get the full precision of the number because JavaScript numbers can't represent all of that data. And so if you want to round trip it, if you want to pass it into JavaScript and then back out, so if you want to get it out of a file and then you want to put it back into some other piece of metadata, you can do that. But if you need to work with it in JavaScript, you're going to need to be careful about the size of the numbers, making sure that that works out all right. So another topic that we saw in one of the demos is the idea of static members. So when you have there's several pieces of functionality which are available, for instance, in the DOM, which are made available just directly off of one of the objects in the system. You don't actually need to go and new something up. You can just ask for it. So in this case, we have a couple of examples of that. When I got that search pane object, we saw that we could just go windows.applicationModel.search.search pane, and then just get the current view's search pane that's associated with the window that you're currently looking at. I didn't actually have to new up a new search pane and then get an object off of that. It's just available as a static property. Similarly, if I want to launch an application, so if I have a URL and I want to just launch that and send it into the browser environment, I can do that through this launcher API, which is available in the Windows runtime. And that launcher API also is just a single static object, the launcher, which I can then go and ask to launch the default program associated with a URL. And so you'll see in the Windows runtime there's actually a lot of these static APIs which are available directly on the constructor objects that are projected into JavaScript. One other sort of interesting aspect of this is always collections. And so when we have collections in JavaScript, we're primarily talking about just JavaScript arrays. And here you see I'm using arrays in a couple of ways. The first one, in replace all there, you see I can just pass a JavaScript array directly into that Windows Runtime API. And this is really important because obviously the way that JavaScript handles arrays and the way that the Windows Runtime handles arrays, those are kind of fundamentally different. But we take care of sort of passing that data along for you. So when you have an array inside JavaScript, we can take care of going and finding the elements and passing them into Windows Runtime for you, so you don't have to worry about that. In the other direction, when I get back a set of files, for instance, when I want to use the file picker that you saw a number of times yesterday to pick some files, either from the local system or from remote, I can use that, and I get passed back a collection of files. And those files, I can use those files in a way very similar to what you're used to when you're working with JavaScript arrays. These obviously are not quite JavaScript arrays. These are a Windows Runtime object, but they have all of the standard things on them. So they have a length property. They have the ability to look up integer index named properties, like files at 0, files at 1, files at 2. And they also have in their prototype chain the array.prototype object, which means that all of the new functionality like for each and map and push and pop are all available on those. So you can write exactly the same code you would expect to write for arrays using these arrays from WinRT that are made available to you. Now, the last one of these sort of drill down topics I wanted to talk about is probably the most important, which is async and the model that we're using there. So as folks talked about yesterday, async is a really important part of the platform. It's something that's really critical to the experience that we're going to offer. And it does mean, though, that developers are going to need to write code. We're going to need to write a lot more async code than even the standard web application is used to. And that's because the capabilities we're giving you access to with the Windows runtime are fundamental capabilities of the system, like accessing the disk and accessing the network and accessing devices. And many, many, many of these things can be slow. We need to make sure that all of those APIs that you access, that can access resources that could be slow, for your users, on your users' behalf, we want to make sure that you're accessing those in an asynchronous way. And so one of the key tasks for us was to make sure that we exposed the asynchronous programming model in as easy of a way as possible in JavaScript. And so there's several models used for asynchronous programming out there in JavaScript. Things like XML HTTP request use a fairly kind of heavyweight system of hooking up a bunch of callback events manually and then sort of calling a .send to kick off the operation. And those are often sort of wrapped with things like winjs.xhr or $.ajax in functions that give a much simpler API where you just pass the sort of on-success callback or whatever else you want to use to handle the error or handle the success or error conditions. One of the patterns that we've seen emerging more recently is something that makes those kind of patterns compose better. And that's a pattern called promises. And this is a pattern that's being used in several other APIs as well, outside of Microsoft. And it's also being sort of documented and maintained in the Common JS group. And so this pattern is represented by a single function that's required on the promise called then. And this function then takes up to three callbacks. And all of them are optional. But these callbacks are what's going to happen, what's going to be invoked when the promise completes. And so the promise, if and when it completes, if it completes successfully, it's going to call that completed handler and pass into it the successful result. If it completes with an error, so if something goes wrong during the operation, we're going to call the error handler. And optionally, some of the APIs that this is hooked up to support the ability to pass progress information. So for instance, if I'm downloading a file, that may inform me as it's making progress, so I can use that information along the way to update my user interface. And so I can pass into this promise.then any of these handlers that I need to write my application, and those will get called back into. So to give you a sense of what this looks like in a standard WinRT scenario, here we've got an example of using that file picker. And so I'm going to pick multiple files asynchronously. And you'll notice that many of the sort of operations that involve using these kind of pickers or other sort of flows where Windows does a lot of work on your behalf, those are going to be async because they could take, those don't just involve the disk or the network. Those actually involve the user interacting with a piece of Windows user interface. And so this is an example. We see that I can call then, and I just pass in a function, literal, right there on the spot, that takes as input the files, and in its body does whatever's going to come next. So after I'm done picking the files, I'm actually going to display that information. I'm going to put the number of files, and I'm going to for each over them and add a line item for each one of the file names. So in the simple example of where I just want to handle the success case, you can see this kind of very simple thing, very similar to what you would see with just basic callback passing async patterns. But the real key to why promises are so important is that when you need to chain these together, which you'll find you often do need to do, it's very important that not become this sort of complex mess of nested functions. And those of you who have sort of worked in sort of highly asynchronous environments are probably used to the kind of the complex nesting you can get yourself into with standard callback-based async. And so with the WinRT and with the promises pattern, we allow you to do a couple of things to make that a little bit easier. So on this example, you'll see that I'm making a slightly different call. I'm picking a single file asynchronously. But then after I get that file back, I'm actually opening the file inside the callback there. And that's also an asynchronous operation because that's going to involve going to my disk. Now, instead of actually nesting all of this and having that be an inner callback that I have to then handle the errors separately for, what I'm actually going to do is just return the result of that asynchronous operation. And then I'm going to continue writing my code on the next line, that var blob equals. And so what this means is I can write my code in a linear style. So I can just do the operations that are actually happening here are just the div.innerHTML line, the file.openAsync line, and then the var blob line. So my code can still structurally be a lot like what I'd expect. But at each point where I need to do something asynchronously, I just return the asynchronous operation and then write another call to then. And so this allows me to chain together a series of asynchronous operations in a much easier way. The other important aspect of this is error handling. And so one of the really nice things about composing together your asynchronous operations is that when you want to handle errors, you can do so in a single place. So even though I made 2 asynchronous calls here, I don't have to handle my errors differently for each of those 2 cases. Any error that happens anywhere in the sequence of operations here will get passed into that final error handler down there. And so this is a really important aspect because as you build up chained asynchronous operations, you're going to want to make sure that you have sort of centralized error handling where all of your errors, you define one behavior for if this operation doesn't succeed, I'm going to display something to the user, I'm going to log something to my server about the failure of the application, and I can do that all from a single point location in my code. So to give you a sense of what some of this asynchronous programming feels like in JavaScript, let me come back over to my demo machine here. So what I'm going to do is I'm going to extend my, app here with another piece of functionality that's available in the Windows Runtime. And to do that, I'm going to come over here into the landing page. So if you remember the application, I'll just run it again to show you really quickly. The application is made up of some groups, and this is the standard template that you'll get if you're building a grid view application. And so I have a sort of grid of different groups, very similar to the sort of start screen. I have my recent group, my favorites group, and my today group. What I want to add is I want to add a new group to this front screen for things that are going on nearby me. And so to do that, I want to actually use some of the geolocation capabilities in the Windows platform. And so what I'm going to do is going to create a locator. So it's going to be windows.devices.geolocation.geolocator. There we go. And I'm actually going to new that up. So now I'm going to get the locator. And the locator has a whole bunch of different capabilities on it. So there's lots of different things I can do using the geolocation APIs in the Windows Runtime. I can set the desired accuracy. I can get the movement threshold for when I want the events to fire, and a bunch of other things that give me a lot of capabilities over the geolocation system. But the one I'm going to use is the get position async. I just need to get the current position and use that to display the set of nearby articles. So what I'm going to do is I'm just going to call that. And then just like we saw on the slides, I'm going to say function position. And there we go. So now I've made an asynchronous call, and I've got some code in here that I can use to look at the position. So just to see really quickly what happens with this, you'll see that now when my application starts, I jump straight into this breakpoint. And this means that I've gotten the position. And let's look at that object that I get back. So this object has both the civic address, which I see is in the United States, and the coordinates that I currently have, so my latitude and longitude. Now I don't have, in my machine here, I don't have an actual GPS device, so the information I'm getting is just based on some of the network information that's available to the system. But you can see I can get a good approximation of my current latitude and longitude. So what I want to do there, I want to say var lat equals pos.coordinates.latitude, and var long is pos.coordinate.longitude. Now that I have this information, I actually want to go off and send that to an API to go and ask me what Wikipedia articles are available near this current location. And so I have an API here. Let me go to the toolbox. Let me go to the toolbox over here. There we go. Okay, so I'm going to use this URL here. And I'm just going to pass in some information. So we saw here it was asking for the latitude, so we're going to pass in the latitude. And then we're going to also pass in the longitude. And now I'm going to use the same as I did before. I'm going to use winjs.xhr, and I'm going to pass in URL as the URL. And what I'm actually going to do is just return that. And so as we saw on the slides, if I return from a asynchronous operation, another asynchronous call, I can just chain those together. So now I can say then function and get the xhr and call that right here. And so let's just do that and see what happens when I get to this breakpoint. So I'm going to set a breakpoint on that line, and I'm going to hit stop that running, hit F5. You see now the application ran, but unlike the last time, I'm not actually hitting this breakpoint. And so I wonder, something's going wrong here. I'm not actually hitting that breakpoint. I wonder why. So I can come back in here, and what I want to do is add some error handling. So I'm going to add another thing to the chain of asynchronous operations, which is going to handle the errors for the whole operation. And you can think of this a bit like a try-catch. So just like you might write a try-catch around some code if you thought that it might fail in some way. Here I'm going to put sort of a try-catch around this whole asynchronous operation. And let me just do a console.log. And I'll print out what that message was. So if I switch back into Visual Studio now, you'll see that I get an error here. So we went into that error handler, and it says the system cannot locate the resource specified. And some of you may already have noticed I intentionally put in a typo there to do that. So, so the URL here actually was not a correctly formed URL, and if I change that, Visual Studio is so nice as to colorize it and tell me that I actually do have the right thing now. And now I'm going to go and hit F5 again. And we should see, there we go. We should see I'm hitting my breakpoint now. So now I'm actually successfully doing those chained async calls. I'm getting the position, and then I'm getting using the position, I'm going out to the network and asking for the results. So let me just again take that data that came back. And I'll just show you what that data looks like. So the data here is a set of articles. Each one of those articles has a bunch of information about what article is available. And so what I'm going to do is just say add topics to group, data.articles, and I'm going to put that in the nearby group. Okay, so there we go. We've written that code. Let me just remove the breakpoint, hit F5 one more time. And we'll see now, if I'm scrolling across here, that now there's a nearby group that showed up. So now just by simply doing that, I made a new group of items appear in my, inside my thing, and we can look up the Anaheim Convention Center, where we all are right now, and see some of the other kinds of events that take place over the year in the Anaheim Convention Center. So very easy, again, to integrate the capabilities of the Windows platform, including things like devices, into your application. And again, like we were saying before, this is just a small amount of code, just 15 lines or so of code, to go and integrate that capability into my application. And I can get that really simple ability available to me. So the last piece I want to talk about is the story for doing Windows Runtime components using JavaScript. So far we've seen in all the slides and demos that we've looked at, we've seen using JavaScript to access the Windows Runtime APIs that are part of Windows itself. So the APIs that a bunch of developers in the Windows team have gone and built to enable you to access Windows. However, the WinRT actually supports exposing new and other kinds of APIs that you guys have built or that other component vendors have built. And these are things we call WinRT components. And so using WinRT components, you can actually write in C# or in C++, you can write components that are WinRT components that are then made available to JavaScript developers. Now this is a really important thing, because this means that as a JavaScript developer, you're not held back by any sort of artificial limitations of what has been made available to you by the platform vendors. This means that when you're building Windows applications using JavaScript, you have access to anything that you would want that a C++ developer could access or a C# developer could access. You can build a component that makes that available into your JavaScript environment. More importantly, component vendors can make that stuff available as well. And so if you have a great sort of open source library in C++ that you found, and you want to use that from your Metro-style application using JavaScript as your presentation technology, you can absolutely do that. And this is a really important capability of the platform. So, that experience is actually really simple. So, for instance, if I want to build a C# component, I can just write some code here to expose a class called moreMath that has a function on it. And here I'm going to be exposing a function called signH, the hyperbolic sine function. This function, obviously this is sort of not the example that all of you guys are going to go out and implement. But it turns out it is something that JavaScript doesn't have today. JavaScript doesn't actually expose the ability to get the hyperbolic sine, but that is something that's available in the C++ and C# environments. We're actually working with the standards body in the JavaScript space to make these things available, to make sure that there aren't these sort of artificial limitations. But in the meantime, if you do want to make that stuff available into JavaScript, you can. This also kind of hints at some of the real use cases you can imagine for doing this kind of thing, and that's things like physics simulation and hardcore sort of heavy lifting math operations that you might want to do as a C++ library, might be already out there as a C++ library. If you need to pull that in and use it from your user interface. Similar to the kind of things that Kieran was showing off yesterday with some of the cool particle simulation that he was doing. So the experience using these kind of APIs, I can author it in C# in a very similar way to what you'd expect. And then from JavaScript, I can use that exactly the same way that you'd expect. I can write sort of moreMath.signH. One really notable thing here, and that I haven't sort of emphasized so far in the talk, but it's really important in terms of the natural and familiarness of the environment, is that all of the APIs that were exposed in Windows, you noticed had sort of their capitalization conventions for members and things like signH here, were what you'd expect as a JavaScript developer. Now, if you went and did that in C#, you'd notice that those Windows Runtime APIs are capitalized in the way that a C# developer expects, which is going to be with an uppercase first letter. We felt to be natural for JavaScript, it was really important that we sort of follow the conventions of common practice for the style. And so here in this example, you'll see you don't have to do any work. If you author your component in C#, you author it in the way that makes sense in C#. And then the way that it gets exposed into JavaScript automatically takes care of sort of giving you the right casing that you'd expect as a JavaScript developer. And additionally, this means that you can reuse that component. You can build a general component which gets used by any of those different environments. And you don't have to worry about things like it feeling awkward in one of the environments or another. It's going to feel natural everywhere. Now, of course, we can do the same thing in C++. We can write that as a class in C++. And we can do that using using the same kind of exact syntax on the JavaScript side. So it doesn't matter which language you use to author it. From JavaScript, you write the same code to consume that API. So let me just really quickly jump in and show you what that looks like inside this environment here. So I'm going to go in quickly. I have my JavaScript project already here, but I'm also going to add a C++ project. Indeed. So I have my JavaScript project. I'm going to add to it a C++ project called myComponent, and this is going to be a WinRT component DLL. So this is the same JavaScript project that I used in the first demo. It just does nothing, blank screen. But now when I add my C++ component, we see that it exposes a bunch of these concepts that we talked about. It exposes events. It exposes methods, which return things like integers. It has properties. And so all the same kind of concepts that we were talking about how they looked like in JavaScript, we have those here. So let me just write that signH function here. Oops. And I'm going to come over to the CPP file and just author that here. Write the signH, double D. I'm going to return, and actually let me just add math.h. I'm going to return signH of D. So there we go. Now I'll just build that. And so I'm now building my C++ component. Now if I come over to my JavaScript project here, I'm going to just do add reference, click solution, add, and close. Come over to here, and now I'm going to say, oops. All right, we're not getting any IntelliSense in here. There we go. Yes, I called it a different thing. So I can type in my component, and I have access to exactly the same API that you saw from the C++. So as soon as we define that component and add a reference to it, it starts showing up in my IntelliSense. And I can come in here and I can sort of new up my component.winrt component. And now I have my signH function available just like I'd expect inside this environment. So let me just run that. So when I run this application, it's actually going to just launch up the same blank application, and it's going to come right back in here. And we see now that I've computed the sign, hyperbolic sign of that number. And so you see right here, this is actually called into a C++ component from my JavaScript code, and then return that to me. So this is an experience that as a JavaScript developer, you don't really typically have available on the web, but when you're building a Windows application using JavaScript, you have access to this kind of capability. Okay, so let me switch back into the slides. Oops. So to recap some of what we just saw there, so we saw that the Windows Runtime provides a ton of new APIs. We touched on a few of them in some of the demos, but there's obviously a ton of new capabilities in this platform. There's sessions all throughout the rest of this week that are going to go into the details on the APIs that are available to you. As a JavaScript developer using these APIs, you're going to use mostly the same kind of patterns you used to. Events are going to be the same. Basic data types are going to be the same. A lot of the APIs are going to feel very familiar to you. There's a few patterns that you're probably going to have to learn because they're very heavily used here. It's like promises. And we definitely encourage you to go and look more at those. Now, specifically what we've shown you in some of the demos, we've looked at how the Windows Runtime APIs can be used from JavaScript. We've specifically looked at how some of the concepts, when you hear people talking about, you'll see posters that have a bunch of namespaces on them. We've talked about how exactly the namespaces are available inside JavaScript. And finally, I've hopefully given you a glimpse of some of the power of what the Windows Runtime can provide to you as a JavaScript developer. And so with that, I'll just mention a couple of related sessions. There's 2 sessions immediately after this that are definitely interesting. One is there's a bunch of things about new HTML5 and JavaScript and CSS3 features that John Hervatin is doing. There's also a talk that isn't mentioned on here about using the WinJS libraries, which you saw me using in a few of the demos there. If you want to learn about those WinJS libraries, I believe the talk is in here after this session. And so I definitely encourage you to go to either of those 2 talks after this one. There's also a few other interesting talks there up on the slides later in this week. And so with that, I'll thank you very much and enjoy the rest of your show.